तो इधर आके बैठ, ठीक है। Starting the class, please. Talking about in probability, we were discussing about how probability questions we have to solve. We discussed two things. First part was mutually exclusive and exhaustive. Understood? So what was the meaning of mutually exclusive? When two different sets like A intersection B, that is coming as phi. This is called as mutually exclusive. Understood? When we are doing different sets are there in probability also, if this will represent sample space, this will be coming as, or this will be called as exhaustive event. Understood? So this is the difference between mutually exclusive and exhaustive. So now one question we are going to solve. In that question, what is exactly given is, good morning everyone. Sujata, good morning, beta. So some very important questions we are going to solve. Let's check this one out. So an experiment is involving, now just listen this one and start solving the questions. So an experiment is there. In that experiment, it is involving, good morning, Siddharth. Vanakkam, Siddharth. Bless you, beta. So now an experiment is there which is involving rolling a pair of dice. Okay, last class we were unable to do this question. So quickly I'm trying to finish this question out. So with a pairing a roll, what you call, we are just rolling a pair of dice and we are recording the event. So pair of dice recording means what and all can be done with pair of dice. Pair of dice is having total 36 outcomes. How many outcomes it will come? 36 outcomes. So with patience, we are going to find the outcomes. But what and all outcomes are there in sample space? The sample space outcomes can be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Okay. And here, second one can be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. Huh? Then 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. Now comes 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Now here next is 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Next one is beta 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So this is exactly total 36 sample spaces there. That means if we are going to add this, it is coming total beta number of sample spaces coming as 36. Now based on this, one question is given. Okay, in that question, A is a set of element. Okay, now what they are telling that a set you have to make where A is a set and this set, this is sample space. Remember, this is sample space. Sample space means set of all the elements. Okay, now the sum is greater than 8. The sum is greater than 8. This is A. What is B? 2 occurs on either dice. 2 occur on either dice. Understood. And the third one is 2 occur on either die. And then third one is the sum is at least 7. The sum is at least 7 and multiple of 3. So this is exactly the situation what they are asking. Payoja, good morning, beta. So this is the situation what they are asking from us, and we have to go for this. Okay. So now what next work we are going to do? What next work we are going to do is, beta, first we will find this one. A. Set A must be having which elements? 6 plus 1, 7. Maximum coming 7. Here it is coming 6 plus 2, maximum coming 8. Here 6, 5 plus 3, 8. They're telling sum should be greater than 8. Then that means first is coming 3 comma 6. Next 4 comma 4 is 8, 4 comma 5. 4 comma 5 and 4 comma 6. Next is 5 comma 4, 5 comma 4, 5 comma 5 and 5 comma 6. And now next one is 6 comma 3, 6 comma 4, 6 comma 5 and 6 comma 6. So this is A. So now we have to find the next one. Good morning, Suprabhat. Now next one is, beta, here 2 occurs on either die. 2 occurs on either die means ki on any one of the die 2 must occur. Understood? So here 1 comma 2 is there na, beta. So here we will write 1 comma 2, then 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5 and 2 comma 6. Now next one is 3 comma 2, 4 comma 2, 5 comma 2 and 6 comma 2. Then third one is the sum is at least 7 and multiple of 3. So here at least 7, but here it you see at least 7 means 7 and more than 7. Okay, so here 3 comma 6 is there, which is divisible by 3 both. Now here nothing is there. 4 comma 5, 4 comma 6 is there. Here 4 comma 9 is there. So 4 comma 5 is 9. So definitely 4 comma 5 is 9. The sum is at least 7 and multiple of 3. When the sum is at least 7 and multiple of 3, shall we take that one 4 comma 3, 4 comma 9? Can we take that part? Siddharth, anyone, because I have just asked this question from you, is it going to be 4 comma 5? The answer is yes. Why? Because 4 comma 5, when we are starting 4 plus 5, because they use the word sum. If they might have written better individually, then we can't have done that. Understood? So here 4 comma 5 is there and we can add 4 comma 5. Now here sum is at least 7. So at least 7, but here 8 and here it is 9, 10, 11. So 5 comma 4 we can take. Now 6 comma 3 we can take. 4 comma 5, 5 comma 3, 6 comma 3 and 6 comma 6 we can take. Any number we left? Can you check? 1, 2, 3, 4, 5. Any number we left in C? No, we have not left any number. We got this all parts. Understood? Now, beta, what we have to do? The question was we have to find A intersection B, and then we have to find B intersection C, and then we have to find A intersection C. Come on, start doing it, because everything I have served, everything I have written. Now only one work for you is find A intersection B, find B intersection C, and find A intersection C. I hope 4 comma 3. Beta 4 comma 3, if we will add, it will become 7. And 7 is not divisible by 3. That is the problem. 4 comma 3 is 7 and sum of 4 comma 3 will be not divisible, beta. So that is the most important thing. We must remember that one. I hope you might have understood this one. Come on, go for it. Okay. Now we will go for the next part. Can you check this one out? So this is exactly one thing, beta. So A intersection B, B intersection C, and A intersection C. So when we have written this one, A intersection C, A intersection B, check beta, anything common coming between them? Nothing common coming between them. That means A intersection B, A intersection B is equal to 5. The moment A intersection B is coming as 5, it is called as mutually exclusive. Mutually exclusive means कि they don't have anything common between them. Understood? So this is mutually exclusive. Now B intersection C, if we will see B intersection C, again nothing is common. So this is also 5. Why? Because they are mutually exclusive. First answer, second answer, third answer. Third answer, again we are going to solve this question. Now is there anything common between them? Is there anything common between them? Look at it. So 4 comma 5, 5 comma 4, 6 comma 3, 6 comma 6, A intersection C. But here 3 comma 6 is there, here 3 comma 6 is there. That means A intersection C, first element we got common is 3 comma 6. Next 4 comma 5 also we got, 5 comma 4 also we got, 6 comma 6 also we got. So 100% 6 comma 6 is there? Yes. So definitely when we talked about all this, we are getting common. So here 1, 2, 3, 4. Let's see any other common. 6 comma 3 is also there because 6 comma 3 was 9. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All the elements. So that means it is not equal to 5. So once it is not equal to 5 means it is not mutually exclusive. So once it is not equal to 5 means it is not mutually exclusive. So this is a way to check mutually exclusive. But probability writing is different, beta. When we are doing probability, they are exactly different. So now probability touch, this is to find which event, means when you are doing two sets you are taking, and when that two sets, Nishika, when that two sets you are taking, the two sets are mutually exclusive or not, that you are writing. But here when they will ask you about probability, that time the word will be different. The word will be how much a, what is the probability of getting A and B together? What word they will use? In the previous question, you got this. Now, beta, in this, what type questions they will ask in probability? First, we need to understand. Siddharth just answered this question. Everybody, Payoja, Siddharth, Sujata, who and all are there in the group, please kindly listen and answer this question. If they will ask this question from you, that question is, I'm just writing, what is the probability after getting mutually exclusive? What is the probability of getting A and B together? Nishika, find, and A and C together. What is the probability of getting A and B together and A and C together? So if somebody will be asking you, what is the probability of getting A and B together and A and C together? If anyone will ask you this question, how we are going to respond to this answer? A and B together. For probability, what we have to do? Probability is understanding only one thing. Probability of an event A and B together. A and B together means whatever should be coming in A and B both. Understood? So now here it should be N of A intersection B. That means how many events are there which are there together, that is N of A intersection B. And then beta, it's sample space. I hope you might have understood. So it's sample space and event together. Sample space and event together. So now here sample space is exactly this one, event is this one. So event is telling 5 and sample space is coming 36. So it is answer is coming as 0. 5 means nothing common. So nothing common means 0. So 0 by 36 answer will come as 36. Now beta, next one, can you check and inform what is the probability of getting A and C together? That is getting number of element in A intersection B by sample space itself. Come on, tell me the answer for this. By sample space itself. So the sample space will be coming how much, beta? A intersection C and sample space itself. A intersection C and sample space itself. What is the answer? Come on, find the answer and inform. What is A intersection C? How many elements are there in A intersection C? 1, 2, 3, 4, 5. 5 elements are there in A intersection C. So what could be the answer? A, answers please. This is very bad. Come on, answer beta. Siddharth, 5 by 36. Absolutely correct. So here it is 5, number of element 5 by 36. And this is a way to approach probability. 5 by 36. Good, Nishika. So both of you got the answer 5 by 36. Now we are going to go to the second stage. Second stage is little difficult. Here I am combining probability and permutation and combination. So you need to listen to the content very carefully. Where and all doubts are there, you please keep asking me doubts. I will clear every single doubts. Understood? Now first beta, one question is there. They ask this for MCQ. Okay. This question mostly they are asking for MCQ. So I am writing S is equal to, just check this one out beta, S is equal to W1 comma, Nishika start doing this, W2, W3, W4 and W5 and W6, and this is NCRT question. This is for your understanding. Okay. Today morning class for 10th is not there. I am having class with 11th also. Okay. So no problem. 10th evening full day you study, full day I will make materials for you. But at least let me spend some time with 11th also. Since morning all people are messaging. 5:30 from that 10th class is messaging. Today 5 hours I'll stay with you. Don't worry. But let me teach them please. So now look here. So W1 event is written. W1, W2, W3, W4, W5, W6. Okay. Avasant. No problem, beta. At least let me spend some time with 12th, 11th and 9th. I'm unable because 12th and 10th is taking so much time. Now beta 6 events are there. Now they're asking, first I'm writing all the situations and then I'm writing the content. You need to understand that is this coming under the format of probability? This is the first part of the question. Like if this is sample space given to you. Okay. After that they are telling that which of the following assignment is exactly coming under the format of probability. Question here is, this is the sample space. Now they're asking which of the following which of the following which of the following assignments of probability is valid. Okay, so which of the following assignments of probability is valid? Valid means which is correct. Okay, so here it is given 1, 0, 0, 0, 0, 0. Second one check. Third one given to you is 1 by 8 and then 2 by 3, 1 by 3, 1 by 3, 1 by 4 and 1 by 4. This is that one. Next one is 1 by 12, 1 by 12, 1 by 12, 1 by 6, 1 by 6, 1 by 6, 3 by 2. Understood? And next one is beta 0.1. Okay, 1, 2, 3, 3, 0.1, 0.2, 0.3, 0.4, 0.5 and 0.6. Now we need to check that which of the following assignments are valid actually. So what is the meaning of valid? Valid means probability na, whenever probability we are finding, the probability sum should be coming between. So whatever events are coming, whatever events we are writing. So here probability of event, whatever events are there, probability of every event, here Wi must be between 0 to 1. Here Wi I have written. Okay, don't get confused by Wi. Wi is any one of it. Okay, wi means I can be starting from 1 and it should be going to 6. Okay, so that means it is events. So every single one is representing a probability. Got it? So beta, look here, probability value should lie between W1, W2, W3, W4, W5, W6. So all these are events. Understood? So now beta, this events, whenever we are going to summarize, it should be coming under the format of, because all are sample space. So there is confusion. They will be thinking that all events are single probability. Then if individually they are not coming under the conclusion of probability, means at least some are coming probability na beta, the answer is wrong. Okay, understand, every individual should actually follow probability, and together also they must follow probability. Why individually following probability first, together because they're asking which of the following assignment of probability is valid. So beta, if we will add all this, how much we are getting? So when you are adding 1 by 6, 1 by 6, 1 by 6, means this situation has to be followed. The first event is 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6. Is it probability? So is it going to definitely follow the rules of probability? What would be your answer? 1 by 6 plus 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 1 by 6. How many times it is coming, beta? It is coming 6 times. So it is coming 6 by 6, answer is coming as 1. So it is following this rule. That means W1, W2, W3, W4 summation of everything is coming as 1. So it is 100% going to be probability. So this probability assignment is valid. So what we will write? Hence, the assignment of probability is valid. So this is there. Now beta, we have solved first one. Can you guess second one, beta? Is second one valid or not? Just say yes or no. Just type like this. Second valid or second invalid, like that. What do you think about second one? Is second one going to be valid? This is our second one. Nishika, is second one going to be valid? 10000. What do you think? Is second one going to be valid? No? Okay, Nishika is telling no. Nishika is telling no. Anyone else who can say is it going to be valid or not? Okay, Sujata is also telling valid. Payoja is telling it is valid. Good. Let's see what Siddharth is telling. See, the correct answer is, come on, I'm waiting for the students to give the answer. The correct answer is it is valid. How it is valid? Now look here. You need to add out everything because individually they are following the rules of probability and together also they must follow the rules of probability. So 1 plus 0 plus 0 plus 0 plus 0 plus 0, 1, 2, 3, 4, 5, 6 beta. Answer is coming as again 1. So since the answer is coming as 1, it is again valid. Now third one. Now can you say third one is valid or not? Is third one valid? Not only individually, together also. So individually they should follow probability, together also they must follow probability. So both should be there, individually also and together also. So you must be thinking about it. Huh? Very good. Is it valid or not valid? Not valid you rate or valid? Because we are going in question number 3. Is it going to be valid or not valid? Just think and say, what do you think? It is coming as valid or not valid? Huh? Not valid. Okay, Nishika is telling it is not valid. What about others, what you are feeling? Is it going to be valid, beta, or not valid? The correct answer is, come on, think here now. Probability this event w5 is less than 0, and W6 is also less than 0, which violates the rule of probability. Okay, in simple, W5 and W6 are coming as negative, beta. So whenever they will come as negative, it is violating the rule of probability. And what is the rule of probability? The probability value should always starts from 0 and greater than 0. It should finishes at 1 and less than 1. Understood? So this is the basic rule. Now beta, which one is the fourth one? You check, is it going to follow the rule of probability? So I have explained this third one till third one we have done. Now fourth one and fifth one, come on, go with fourth one and fifth one. Anyone answer? Is it going to be valid? Come on, answer please. Is it going to be valid? What are you thinking? Is it going to be valid, beta? Nishika, is it going to be valid? Come on, check. Together, first we need to see individually. Afterwards, only we can think about together. First, check individually. Once individually it is doing means together also it can do. It is not a big deal. Valid? Okay. Sujata told it is valid. But first we have to check individually. 1 by 12 less than 0. 1 by 12 less than 0, both are valid. 1 by 6 less than 0, both are valid. 1 by 6 also less than 0, valid. 1 by 6 less than 0, valid. Now 3 by 2. Is it valid? Payoja is telling not valid. So what is the correct answer is 3 by 2 is greater than 0. So it is not valid. But individually also they have to satisfy the condition and together. But there na pair of event dice, there you need to understand that why we are saying like not valid. Absolutely correct, Siddharth. So beta, understand this. Previous question we have done na, then you will be asking a question. Auntie, in previous question when we were discussing, A came. Beta, we only got A. We did not got probability of A. Just remember that one. We got only event A, set A, set B, set C. Probability of an event means it must follow this rule, beta. Simple, remember. Now, beta, is this fifth one, quickly say, is it going to follow the rule of probability? This one? Individually, so they are following. Individually, all the events are following. But is together they are following this one? Check. Together, are they following the rule of probability? Because together when we are talking about the assignment of probability, individually W1, W2, W3, W4, everything is satisfying. But better together, are they satisfying? Let's check. Are they satisfying together? Individually, everything is less than 1. Correct, na beta? But by seeing this 2 itself, na, if we will add this 2 itself, it is coming as very good, Siddharth. So it is exactly coming what? 0 0.5, 0 0.6. 0 0.5 and 0 0.6 you add, it is coming 1.1. But probability should never come more than 1. So here itself the story over. Then this one counting means this one adding means it will go more than 1. Correct, na? This one counting means this one adding means it will go more than 1. So this is not going to be accepted. So this is exactly one of the terms we are using in probability. So this is a way of checking assignments of probability. Understood? And always beta, we do one very important work whenever we are doing probability. Event by sample space is probability. A single set is not probability. That must be remembered. Understood? So this is a way of handling probability. Now we will make something little difficult. Got it? So now probability of event whenever it will be coming. How we are going to solve a question I am giving, and we will be solving this question. Understood? Then we will go for different approaches. A die is thrown. Find the probability of getting. A die is thrown. First, starting with a simple question. A die is thrown. Find the probability. Find the probability of getting. First, started with a very simple question. 1, 2, 3, 4, 5 questions in this. Find the probability of getting even number. In short, I am writing. Second one is prime number. Okay. Third one is a number greater than 3, greater than or equal to 3. A number greater than or equal to 3. Fourth one is a number less than or equal to 4. A number less than or equal to 4. Okay. Next, a number less than or equal to 6 is there. Now, a composite number. Got it? So now start solving the question. Very good. Absolutely correct, Siddharth. First one itself you hit it. So beta, one die is thrown means 1, 2, 3, 4, 5, 6. First event is E1. E1 they are telling that first event E1. E1 they are telling that it should be even number. Even number is 2, 4, 6. So sample space is coming as 6, and here event E1 is coming as 3. So probability of getting event E1 is NE1 by NS. So it will come 3 by 6, that is 1 by 2. Absolutely correct, Siddharth, first one. Super. Second one is also coming as 1 by 3, 1 by 2. Super. So second one is what? Event 2. Second event is what? Prime numbers. So what and all prime numbers are there? 2, 3 and 5 are prime numbers. So probability of getting this one, 3 is coming. So probability of getting event 2 is equal to NE2 by NS. So that is coming as 3 by 6, that is 1 by 2. Now third one is a number greater than or equal to 3. What can be answered here? A number greater than or equal to 3. Very good. A number greater than or equal to 3 means any number which can be greater than. So event can be a number greater than or equal to 3 beta. Absolute. Second one, third answer Siddharth has given. Fourth also answer Siddharth has given. After this, Sujata has given answer D, E. Super. So now look here beta. Fourth and third, we are going to check. Fourth is number that is 3, 4, 5, 6. So here event is coming. Number of element in event 3 is coming as 4. So probability of getting this event is 4 by 6, that is 2 by 3. Absolute. Now fourth one beta, event 4, number greater than 4. So number greater than 4 is equal 4, 5, 6, 3. So it is coming probability of getting E4 is 3 by 6, that is again 1 by 2. Super. Very good. Last one here. Last one, what is the answer? What you felt for last one? A composite number. Among them, which one is composite number? Very good. Last one answer has been given by Siddharth and 4 and 6 are composite numbers. Absolutely correct. So composite numbers are two composite numbers are here. So one time I'll explain 2, 3, 4, 5, 6. So which numbers are composite number? Here its factor is only 2 1, its factor is only 3 1, its factor is 2 1 4, its factor is only 3 1, its factor is 2 3 6 1. All these are exactly coming. So here these two numbers are having more than two factors. Okay, so whenever numbers are more than two factors are there, more than two factors means these two numbers will be exactly coming. So here what and all things are there we are going to write. So here probability directly will write approach E5 is coming as 4 and 6. So number of element in E5 is 2. So probabilistic approach for E5 will be 2 by 6 and that is 1 by 3. Well done children. Everyone is absolutely correct. Super. So this is one question we have solved. Okay. So now we are going to go for some little bit tricky questions. Question is, suppose each, I'm reading the question nicely, you need to write down and just start answering the questions. Okay, because now the level of questions will get little bit trouble, because beta two dice related question and two what you call coins, three coins related question, at least at most you will be able to solve. That's not a big tricky questions, but the tricky questions lies where your content will change. Okay, like a fair coin with one marked on one face and six marked on other face. So one coin is there. In this coin, one is marked in one side, its opposite side flip if you will do, you will get six on the other face. Okay, so one coin is there, one side one written, another side six written. Understood? So now what is there? A fair coin with one marked on one face and six on the other, and a fair die. And a fair die. Fair die means beta which will have six numbers. Understood? They both are rolled together. Got it? Coin is having what written? 1 and backside written 6. One side 1, another side 6, and one dice is rolled. Got it? These two things are rolled. So what can be? So coin, two faces are there. This is about coin. And dice, we know that dice are exactly having how many faces? 1 2 3 4 5 6, and both of them are rolled together. This is the thing, both of them are rolled together. So when these two things are rolled together, how we are going to do? So here one will be with all the six, so it will become 1 1 1 2 1 3 1 4 1 5 and 1 6. Understood? Second one is 6. 6 1 6 2 6 3 6 4 6 5 and 6 6. So this is the entire sample space beta. Now I'm asking the question, get ready, because beta coin two faces were there, 1 6 and this one. So now beta first question is, find the probability that the sum of number will turn up 3. Sum turn up 3. Understood? Sum turn up 3, first part question. Sum turn up 7. At least it should be 5. Sum at most 12. Try this question. Yes, at least 5 and at most 12. So you have all the questions inside. Nishika, can you start answering the question? Sum turn up as 3. Total sample space is coming as how much beta? Total sample space will come as 12. Total sample space is coming as 12. Come on, start trying the question, please. Total sample space is coming as 12. Then what answer we are going to search here and find? Total sample space is coming as 12. So as total sample space is coming as 12, Rudra 1 by 12, first one, super. Turn up, sum turn up 3. How many are coming? Only one is coming as 3. Super. Super, Rudra. Correct only. Hi Jay, so look here. First part is beta, first part of the question is what? E1. E1 event is only coming as beta. Hi beta, just try this question. So here it is coming 1 plus 2. So even event is coming only beta 1 plus 2 super Rudra. So the probability of getting event 1 is 1 by sample space is 12. So 1 by 12. This is the first answer beta. Now can you attempt the second question beta? Sum turn up 7. Anywhere 7 is there? 6 comma 1. Only 1 is there or 2 is there? Come on, try to solve the question. Very good. So event will be coming. Second case event is coming as 1 comma 6 and 6 comma 1. So here probability of getting event 2 is number of element in event 2 is how much beta? 2. So it will become number of element in event 2 by sample space. So it will come 2 by 12 and that is coming 1 by 6. Absolutely. 2 by 12 and that is 1 by 6. But a third, sum at least 5. Sum at least 5. What is the meaning of having? Absolutely correct, beta. 2 by 12 is 1 by 6 is absolutely correct. Now you need to talk about this one, sum at least 5. So if sum at least 5, somebody will be asking you how you are going to respond sum at least 5. Some at least means if somebody is telling that okay, I can eat at least 2 chapatis, means 2 is my lower limit. More than 2, I can eat anything. Understand or not? More than 2, I can eat 200 chapatis also. So here they are telling at least 5. At least 5 means 5 and more than 5. At least 5 means 5 and more than 5. So what can be answered? Payoja has given answer 3 by 4. Let's check this one out beta. More than 5 means here 5 and more than 5. Let's talk about it. So here 1 by 4 itself is crossing 5 now. 1 by 4 will come because it is 5. Then 1 by 5 will come, it is 6. And 1 by 6 will come, it is 7. So that means 5 and more than 5. So this 3 is coming. Then here to all are greater. That is 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5 and 6 comma 6. So with a total how much is coming? 1, 2, 3, 4, 5, 6, 7, 8, 9. So probability event is coming as 9. So probability of getting this event is 9 by 12. That is 3 by 4. Absolutely correct. The answer is coming here as 3 by 4 beta. The answer is coming here as 3 by 4. Little bit I need to. I hope now you have understood the answer is coming as 3 by 4 beta. So this is the apt answer and this is the question. This question was NCRT question. Little bit I have changed the question so that you can understand the question nicely. Now beta, next question is, we are going to solve some questions like this and we are going to solve some little tricky questions also. The question here is, now you have to find what is the probability that a leap year selected at a random will contain 53 Sundays. What is the probability that a leap year selected at random will have 53 Sundays? Okay, so this is the question. What is the answer here? This is the question. So what can be the expected answer? First, you remember one thing. Whenever we are solving this question in class 10th, I taught to Payoja, Siddharth, this Rudra, this question I have given a very shortcut format. I told total it will be this one, but now I'm going to elaborate it and teach beta how it is exactly going to be and in which way it is going to be. Just understand one thing beta, when it is a leap year, so in solution how we are going to attempt, in solution how we are going to write fully. For leap year, how many days are there? Yes, Peter. Rudra, 1 by 7. No, this is a leap year. Leap year is having how many days, Peter? You remember, Rudra, we discussed about it, but non-leap year we have discussed. Check one time. 366 days in leap year. Understood, Peter? So in leap year, 366 days. That means it will have 52 weeks and 2 days. How beta? We will divide it by, because a week consists of 7 days. So 7 days, 7 fives are 35, and here it is coming as 1 6. So 7 twos are 14, 2 remainder is coming. So that means what beta? So it is exactly coming as 52 weeks and 2 days. So 52 Sundays packed. It is not going to change. Now that 2 days. Now we are going to find sample space. Sample space will come as what? That 2 days can be, because we're not bothered about 52 weeks. 52 weeks gone there. So now we are going to talk about sample space. Sample space says that it can be Saturday, Sunday. It can be Sunday, Monday. It can be Monday, Tuesday. It can be Tuesday, Wednesday. It can be Wednesday, Thursday. It can be Thursday, Friday. It can be Friday, Saturday. Okay, beta, like this. So total sample space is coming as how much, beta? Total sample space is coming here as 1, 2, 3, 4, 5, 6, 7. So your total sample space is coming as 7. Understood? Now, beta, they're asking the 2 days can be Sundays. So which event is going to be taken? The event of having Sundays can be how many? Two are there, 1 and 2. It can be Saturday, Sunday or Sunday, Monday. So event can be Saturday, Sunday, 2 days together, or Sunday, Monday. More than that, we cannot skip the part. So here, event is exactly number of element in event is 2. So what is the probability? The probability of having this event is 2 by 7. Understood better? The probability of having this event is 2 by 7. So now if somebody will ask you, this is for leap year beta. This is for leap year, we are doing this. Now non-leap year, Rudra. When non-leap year will be there beta, then here rather than writing 366 days, how many days we will write? 365 days. That means 52 weeks and 1 day extra. Now, what is the sample space? That sample space can be any one of the day, like Sunday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So that means beta sample space will come here also 7, but non together. Here it is together, Sunday, Saturday, Sunday, Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, like that. Now beta here it is coming as 7. So now what is the event? Your event of having Sunday here is only one, that is only Sunday. So that means NES will come as 1. So probability of event getting this is 1 by 7. Now I hope my children might have understood what is the difference between writing 2 by 7 and what is the difference between writing 1 by 7. Come on beta, did you understood? Everybody understood this one? Ki how we are approached to Saturday, Sunday. This is sample space beta. 52 is packed. So 52 will not change. What sample space is bothered about? So sample space is exactly considering the points where Saturday, Sunday, Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, like that coming together. I hope all of you understood this one. But is it easy to understand? Is it okay? Is it okay, beta? Yes, very good, Paja. Rudra understood beta. Siddharth, Rudra, Payoja, Sujata, everyone understood beta how to go with these questions beta. So this is exactly the way to handle this question. Now we are going to go with another level questions. Now little bit increased tendency we are going to increase, and we are going to write better, because most of the time they will not be giving like this type of questions. When you are going for competition and when you are going for different level questions, that time, yes beta, that's what Sutrudra, that time you are the first one, I remember you have answered all these questions there, but only one thing you missed here, that is leap year. Now look here, beta. We will go for the next part. In the next part of the question is three dice are thrown together. Here, how many dice are thrown together? Three dice. Three dice are thrown together. So that means, beta, together these three dice are thrown. Understood? So three dice are thrown together. After that, find the probability of getting a total of at least six. A total of at least six. Find the probability of getting a total of at least six. How can we attempt these questions, beta? A total of at least six, they are telling. A total of at least six. Is it going to be possible? Because sample space itself, number of see, when two dice are, if one dice is there, if one dice is there means sample space is coming as 6. Two dice is coming, sample space is coming as 36. Three dice means how many sample space will come? Deshika, if three dice are tossed together, sorry, thrown together, rolled together, how many total sample space will come? 6 to the power of 3. That is a total of, very good Payoja. 6 to the power 3 is total of, yes, it is a total of 216. So how can we be able to find that it should be at least? At least means, beta, at least here is a very poisonous word. Why? Because here at least they have used the word. At least when we are using the word means 6 and more than 6. Understood? Some should be 6 and more than 6. When we can get 6 and more than 6. So first one is we need to find less than 6. Got it? If less than 6 we are finding, so we will write event E1 sum less than 6. So if event E1 is less than 6, then E1 bar will be not less than 6. Means E1 bar is teaching, E1 bar is greater than 6. E1 bar is greater than 6, and we know that probability of this approach is probability of getting an event and probability of not getting an event is equal to 1. So this is exactly the one we are going to find. So here E1 is some less than 6. But we have to find not less than 6, because they told at least 6. At least 6 is a total of at least 6. So which one we have to find? See, statement should be according to your priority. You can write as here some at least 6, some not at least 6, like that. Some at least 6, some not at least 6, because event is like that. So I'm just changing the statement. It is not going to work, but the content, it is not going to be, sorry, it is not going to be important like what you are writing. It should be according to you. The question should flow according to your thought. Okay, so we are going to write some at least 6, and this one not at least 6. Understood? So not at least 6. Not at least 6 means less than 6. At least 6. Opposite to at least 6 is not at least 6. Not at least 6 means it will be less than 6. So if, see, understand one thing. I'm saying that ki I'm starting the work. Starting the work means I'm eating two chapatis, at least two chapati. Means if I'm saying I'm eating at least two chapati, then what is the opposite of that statement? Not eating at least two chapatis. Not eating at least two chapati means I am eating less than two chapatis. I am eating less than, yes, at most is opposite of at least. Understood? You need to understand here. So here, some at least six. This we have to find. But here, not at least six. We can write any statement here less than six. At least less than six. So beta first we have to find this one because this is a very big target box. We can't achieve that. So first we know that 111 is possible, 112 is possible. Now you see 2 plus 3, 3 plus 4, 113 possible because the moment we are writing 113, 3, 4, 5. Now at least 6 means 6 and greater than 6. But here it is coming 5. So now it is not possible. Next one we will do 1, 2, 1, 1, 2, 2. That's it. Because 2 plus 3 plus 4, here it is coming as 5. More than this, we can't do that. Okay. So now next one is because 1, 2, 3 we will take. Not possible. Now 1, 3, 1. 1, 3, 4 plus 1, 5. This is packed. Now 141 we can't take because the moment we are writing 141, 141 will become 6. 151 we can't take. So now after that we can't do anything. Now we can start with because 111 is there. So we will write as 112. Already we did. Now 121 also we get. Now shall we start with 211? This location 211. So 4 is coming. 221. 5 is coming. More than this we cannot take. Understood? So favorable, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. Any other number is there? Can I write here 311? 311. Okay. So after that, can I write 313? Huh? 321 we can't take. 321 we can't take. Now any number is missing here because 211 is there, 221 is there, 212 also is possible, 212 is also possible. 212 is also possible because 5 is coming. Now we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly 10 is coming. Here exactly 10 is coming. Now more than this bit are not possible because if we will go with 312, 331, 321, everything is greater. That means some sample space of not getting is coming as 10. But we want this one, E1. So probability of getting event E plus probability of getting event E bar is equal to 1. This is our situation. Okay. So once this situation is written to us, how we are going to proceed? So beta not E1, E1. So this though we have to find plus this one is coming as 10 by 216 equal to 1. So probability of getting at least, probability of getting this is coming as 1 minus 10 by 216. So it will come 216 minus 10 by 216. Answer is coming 206 by 216, which is less than 1. So answer is absolutely correct. 206 by 206 by 216, which is less than 1. So once we are solving like this, the answer is exactly correct. I hope everybody understood this one, how to attempt these type of questions, beta. Is it okay? Is it okay? Did you understood how to attempt these type of questions? Did you understood this one? So we are going to solve some more questions like this in coming time. So this is exactly the way to proceed, beta. So I think probability one approach point we have reached where we have understood like, okay, fine, this type of questions only we have to solve. But there, beta, more complicated questions are there. In two more classes of probability, very good. In two more classes, 2 to 3 more classes of probability, we will do now complicated questions. Some complicated questions where combination is needed, some complicated questions when permutation is there. My plan was to start today itself, but first we should understand the basics. So after that, it is we can be able to. So thank you, Vita. Thank you for joining the session and understanding. I hope you might have liked the class. You might have enjoyed in the class. So this is the answer. After that, you can convert it into simpler point also. Okay. So maybe I'll fix the timings, because one class day before yesterday's class was hanged because of network. So 100% two extra class I'm going to give. Okay. Bye everyone. Good. Have a nice day.